In this video, we will be looking at standard deviation. By the end of this lesson, you should be able to, given data, calculate and interpret standard deviation. You'll be able to explain ways in which standard deviation addresses dispersion differently than box and whiskers. So here we have situation number 1. We have 3 sets of data. Each of these data sets has a mean of 20, so they have the same mean. Order these sets from greatest standard deviation to least standard deviation, okay? And down here we have the definition of what standard deviation means. Standard deviation is a statistic that measures the spread of the data away from the mean. Okay, remember our mean is our average of the data. So standard deviation measures how far away from the mean the data points are. So that's what we look at when we look at standard deviation. So if we're looking at these 3 sets, set 1 and set 2 and set 3, we're looking at how spread apart they are. And our question says to order them from greatest to least standard deviation. So if we take a look at set 1, and if they have a mean of 20, we're looking at how far away from 20 our numbers generally are. So if we look at set 1, we have 18, 19, 20, 21, and 22. Our numbers are generally pretty close to that 20. They're within 1 or 2 data point from 20. Set 2, notice that they're all the value of 20. So there is no distance from 20 in set 2. In set 3, if you notice that we have 16, 18, 20, 21, and 25, we are further from 20 in this set. So if we want to order them from the greatest to the least, if we look at here, let's just estimate for now, and we'll come back and we'll calculate later on. But if we estimate right now, just looking at the numbers, it appears that set 3 is the most spread. Set 1 is a little bit closer together, and set 2, being all 20, has the least standard deviation. So we can actually calculate standard deviation instead of estimating. So we're going to use our calculator to find the mean and the standard deviation. So in our first example there, they gave us the mean. So we are going to calculate the mean ourselves. So if you take a look at a calculator, we want to go ahead. We've used this before. We're going to hit the stat button, okay, edit, and we're going to put the data points in. If you have any data points, you might have to clear them out. Okay, so I'm going to enter in all these data points into my L1. Once you have all your data entered, you just want to double check that you have all of them correctly. If we notice here, I have 14 points, and if I'm down here, I can see 14, and I just want to double check that all the numbers are correct. Once you have all of your numbers correctly in your calculator, you're going to go back to stat, which we've done before. In the past, we've gone over to calc and looked at our linear regression and our quadratic regression. But today, we're actually just going to stay up here at number 1, one variable stats. That's what we're looking at today. So we're going to hit enter, 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 enter. And if we notice here, we're given a couple pieces of information. The first one I want to look at here is where it says X with a little bar over it. That is going to be my mean here. That's my mean. So I'm going to go back and write that down. My mean for this data set is 5.5. The next thing I'm looking for is my standard deviation. So that's that funny little curve with O with the curve on it here. That's going to be our standard deviation symbol, and that is 2.5. That's all we're going to look at on this list for today. We may come back to this list for some more information later on. So we can get our mean and our standard deviation from the calculator. And those instructions are on your notes. Stat 1, enter the values into your L1, stat, enter, and then you just want to make sure you look at this symbol for the standard deviation. So now we're asked to map the data set on this number line. So we want to plot our points and look at what standard deviation looks like on a number line. So we want to find our mean first. So my mean is at 5.5, which would be just about here. That is my mean. So I'm going to put here, we have another symbol right there for our mean. It's kind of like a cursive U there for our mean. From there, we're going to label our standard deviations. If we notice, our standard deviation was 2.5. So that means I'm going to first go above my mean here. So one standard deviation above would fall here at 8. Okay, 5.5 plus 2.5 lands me at 8. That is one standard deviation above the mean. I can go another standard deviation above the mean by adding another 2.5. So 8 plus 2.5 is going to land me here at 10.5. That is going to be 2 standard deviations above the mean. If I add 2.5 again, I'm going to land here at 13. That is going to be 3 standard deviations above the mean. And lastly, what we can fit on this number line is our last one. If I add another 2.5, I'm over here at 15.5, and that is 4 standard deviations above the mean. So I've gone above, I've added 2.5 each time. I can also go below the mean by subtracting 2.5 in the other direction. So here if I take 5.5 and I subtract 2.5, I land at 3, and that is minus 1 standard deviation. So that's 1 standard deviation to the left. If I subtract 2.5 again, I land at 0.5. That is my 2 standard deviations to the left. If I subtract 2.5 again, I'm left at negative 2. And that is 3 standard deviations to the left. And if I subtract it again, I'm here at negative 4.5, which is 4 standard deviations to the left. Notice how each of my standard deviations follows this increment of 2.5. If I'm going above the mean, I add 2.5. If I'm going below the mean, I'm subtracting 2.5. So now we're going to answer some questions based on our number line and based on this data set. So which values in the data set are within 1 standard deviation of the mean? So within, meaning we're looking at from minus 1 standard deviation to 1 standard deviation from the mean. So we're looking at from 1 standard deviation from on the left and 1 on the right. And those numbers are from 3 to 8. So I'm looking at my data points, and I want to find my data points that are from 3 to 8. I have quite a few there. So I have 3, 4, 4, 4, 5, 6, 7, 7, and 8 are all from 3 to 8, which is 1 standard deviation below and 1 standard deviation above the mean. So our next question says, which values are between 1 standard deviation and 2 standard deviations? So again, here we're looking at from 1 standard deviation to 2 standard deviations. And if I look back at my number line, 1 standard deviation is at 8 and 2 is at 10.5. So what data points are from 8 to 10.5? So those data points are 8, 8, 9, and 9. Those data points are between 8 and 10.5. Our next question says, which values are within 1.5 standard deviations of the mean? Within 1.5, if I notice, I don't have 1.5 on my number line. So you can mathematically compute this as well. So it's the same idea. We're going from minus 1.5 standard deviations. When that's within, it's below and above, to plus 1.5 standard deviations. Okay, so what we're going to do here is look at from our mean, which is 5.5. We're going to look at it below, so minus 1.5, which is what I'm looking at, my how many standard deviations, times my actual standard deviation, which is 2.5. That's going to tell me where I'm at below. And when I multiply that, if I enter that in my calculator, I will get 1.75. And again, that was the below part. So now I want to look at above the mean. So I want to do 5.5 plus, instead of minus, 1.5. That's how many standard deviations I'm looking at. And my actual standard deviation is 2.5 is equal to 9.25. So what data points, which values are within that range? So I actually have a lot of values in there. So those values are going to be 2, 3, 4, 4, 4, 5, 6, 7, 7, 8, 8, 9, and 9. So almost all of our data points, except for one, are within 1.5 standard deviations of the mean. If we look at our next question, it says which values are more than 2 standard deviations away from the mean? Which values are unusual? So again, even though you just see this positive 2, when it says 2 standard deviations away, we want to take into consideration above and below the mean. So we want to find values that are above 2 standard deviations. Okay, so let's look at that first. Ones that are above 2 standard deviations. So for that, I'm going to take my mean, 5.5, plus 2. That's how many standard deviations? My standard deviation is 2.5. And there I get 10.5. Okay, so I'm looking at above, values that are above 2 standard deviations is 10.5. Anything that's above 10.5. And then if we look below, we want to go less than negative 2 standard deviations. So we're looking at data points that are above 10.5. And now let's look at what we're looking at here. So we have 5.5 minus, this time we're looking at below, same thing, 2, 2.5 is my standard deviation. So here that would be equal to 0.5. So we're looking for numbers in our data set that are greater than 10.5 or less than 0.5. But if I look at my data set, I do not have any data points that are greater than 10.5, and I do not have any numbers that are less than 0.5. So there are none that fall into this category. And we would call, if there was any numbers, we would call these unusual. They would be unusual data points if they were greater than 10.5 or less than 0.5. And lastly, it asks how many values are below the mean. Well, I know that my mean, I have two symbols for my mean, is 5.5. So how many data points are less than 5.5? So I'm going to list all of those. So here, there's my 5. All the data points are less than 5.5. So 5.5 would be in between 5 and 6. That's everything to the left here. So I have, these are my data points that are less than 5.5. And I have 1, 2, 3, 4, 5, 6, 7 of them. So I have 7 values that are below the mean. We've reached the end of the video. We will continue to practice this together in class and continue to work with our standard deviation.